It'll take just a couple more seconds.
Yeah, no problem. Take your time.
Okay, we're live on YouTube. You can take it away. I'll drop the link in the chat as well.
Thank you, David. Thank you. All right, then. Hello, good day, good morning, good afternoon, everyone. Welcome to the Hyperledger Toronto Meetup Group's monthly event. My name is Laszlo Sándor, and I'm one of the co-organizers of this group. Today, we have an excellent speaker and a very good, very interesting topic, which is about Hyperledger Fabric scaling in a cross-cloud environment. And our today's speaker will be Tsvetan Georgiev. He is a co-founder of a company called Senofi, where his main focus is product development, product management, and development of Consortia. Even before he founded or co-founded Sanofi, he'd been in blockchain and had experience with implementing Hyperledger Fabric networks in many and multiple industries like healthcare, insurance, and so on. He brings 20 years of enterprise software engineering experience. And personally, I met him a couple of years ago, or several years ago by now, when he was with the previous company and they did Hyperledger Fabric training in Toronto. And I liked it a lot. I think that time many companies tried to open courses on blockchain and Hyperledger Fabric, but I found his material and his classes very useful, which I used it for a long time after. Before I give it over to Tsvetan to take it away, I like to make a very quick announcement, and I hope you will like it. I'm just preparing here for a sec. So in the second part of the hello? If you don't mind, everyone, just muting your microphone except Tsvetan would be great. So today I'm gonna do a draw, and I have a prize for you, which I'm gonna show you. It's a real, original, unused, unpacked IBM blockchain stocks. This is a one size fits all, made in the USA. So only, if not for anything else, only for that is a very unique gift. And it says IBM blockchain. Unfortunately, this time you can't really show off with it, not even at the global forum, which will be, as David mentioned, in June and will be virtual. But if you would like to have these socks, which I just showed you, when you send a question in either in the chat in the Zoom or on YouTube, I will keep an eye for that. Also mention your city, and at the end I will draw someone, and we will figure out how can I mail this to you. Without any further ado, I like to invite Tsvetan on the stage, and please take it away.
Thank you, Laszlo. Thanks for the nice words. Yeah, let's dive into it. A bit of yeah, you said a lot about me. Thanks for the nice words again. Let me see how I can flip the slides. A bit more to add on what I'm doing professionally. Again, we are actually focused on Hyperledger Fabric as our technology stack, and our main product, apart from the services we provide for the projects, is Consortio, and that is a software as a service. You can think about it like that, to accelerate the management deployment of Hyperledger Fabric networks and applications. We fill the gap that was there since the beginning to actually manage those networks across clouds, across business partners that are on the consortium. And that is very essential part, because that brings a lot of complexity. And even though the steps to do that management are pretty well described and clear from documentation point of view, from community point of view, they're all manual. So that's why we built Consortia to automate all of those steps and make it easier for the end users to manage the Hyperledger Fabric-based networks and applications. So let's now move to the agenda. Why scalability? Scalability is very extremely important topic. It is not just for Hyperledger Fabric, of course, or any blockchain. We know scalability is a big topic also for public blockchains, and actually it's a valid thing for any software. What I know, it's not simple. It's even more complex when you put it in the context of distributed technologies like Hyperledger Fabric. So in the session today, I will be focusing on Hyperledger Fabric in particular, but have in mind that the concepts I'll be talking about are valid almost for any ledger out there. Of course, it is in the context of private and permission blockchains, not in the context of public blockchains like Ethereum or Bitcoin. I just want to make the draw the line, because it's extremely different to actually the way you manage scalability on those networks. And have in mind that permission private networks are more or less networks that a particular set of partners have control over. So that's what we'll be talking about today. So the agenda is, I will just quickly talk about what scalability is in general, just to set the context right. So you know what areas will be discussed, and then I will be actually focusing more on to what scalability means for distributed ledger technologies and Hyperledger Fabric in particular. And it's not just about talking for software scalability in general. It's more or less what are the most essential and important topics or constraints, you know, around scaling private and permission networks. And of course, we will talk about how to do that across clouds. It is not that it's you can do it on one cloud, of course, but have in mind those networks are heavily decentralized and distributed. So it is very realistic to expect that they will work on different clouds. That's why, or infrastructure, it's not even necessarily a cloud. That's why a cross clouds topic is essential. And I will leave 25 minutes, hopefully, for question and answers. I want to take probably half an hour to go through the content and have an open discussion, make it more interesting, and probably answer questions and have a brainstorm or discussion on it. So in general, what scalability is, it is very broad topic, to be honest. I'm not claiming I'll cover everything. Don't get me wrong. It's extremely technical and complex. There is a lot of theory behind that. I just put a couple of dimensions here that are actually essential. This is scalability in terms of you call that administrative scalability. That's actually the context of increasing the number of organizations or users that access the system. That is very well handled properly by because it's in the nature of it by Hyperledger Fabric in terms of scaling your channels by adding more organization, more peers on the channel, and all of that. So this is given more or less out of the box by the technology. You have, of course, the functional scalability. Shortly, it is about enhancing the system by adding new functionalities. Again, very well implemented in the context of Hyperledger Fabric. It's not just about chain codes, of course. I'm talking even about the so-called plugins, where you can actually adjust the network behavior on the peer level by implementing some system chain codes, for example, to verify to change the default behavior of how transactions being verified when they're committed by the peers. Geographic scalability, again, very essential part. We're talking about heavily decentralized distributed systems. So having your peers running in different areas, even though it could be on the same cloud provider, again, having high availability by distributing or reducing the risk by distributing the nodes into different geographical locations is essential. And of course, load scalability. Think about it in lame words. It's when you actually want to scale up or scale down your system depending on the load you have on it at a particular point of time. This is essentially extremely complex in terms of Hyperledger Fabric if you look at the network as a whole. And we'll go through those things in a minute or two. And of course, horizontal and vertical scaling, I think they're the most famous or the most talked about in the industry. It's about extending or adding, essentially that translates technically into adding new peers on the network to handle a higher volume of users you might have. And this is very interesting thing in Hyperledger Fabric because it could be actually handled by every organization separately that is joined on the network. And vertical scaling, again, the same thing. It is handled by every organization in particular, and it is about adding new computational resources, for example, increase the number of CPUs. And here, of course, you could do dynamic scaling, which is not simple to do, of course, is to scale up or down depending on the load by adding dynamically CPUs or memory or storage. So what is actually, before we start talking about those concepts in the terms of in the context of Hyperledger Fabric, we will talk about what a Hyperledger deployment actually usually looks like. So first of all, I just want to mention that with the distributed and decentralized networks, it is not one-time thing in terms of topology. It is not something that is set in stone. Those networks are actually designed and supposed to grow or actually reduce in size. Speaking of, considering the number of organizations, maybe organization or business partners will join the network. Some may leave the network. New peers will be added. New peers will be removed. So that's why the deployment that you usually start with over time changes significantly. So when you are organizing, the first thing you do usually is to organize your infrastructure. Think about it, the machines or the computers that's gonna be used to manage the load or to run your nodes, your peers, orders, and all of that. So this is where you actually decide on what infrastructure to use, and usually people go with different cloud providers, or maybe the same cloud provider and different geographic locations And the reason is I already explained why it's important. Then you deploy your organization and nodes. From Fabric perspective, it is not, it's a bit different, because organization from Fabric perspective means membership service provider, and organization from business point of view may be a real corporation or company, right? So one company or one corporation may, of course, have multiple Fabric service providers that from Fabric perspective are different organizations. So you deploy your nodes, you deploy your applications. Those are usually the chain codes, and probably you want to expose that functionality on in some kind of a web APIs, through some web APIs, and expose some UIs to your consumers. Those consumers, of course, could be your clients or maybe internal clients of your solution, depending on the business case. And of course, last thing that is extremely important and complex to manage is the network governance. There have been efforts to actually streamline the governance process across providers. But yeah, so far it is something that is out of bound from Hyperledger Fabric perspective. So what is actually about now scaling about Hyperledger Fabric networks? So first is about scaling the consortium. Okay, so it is here not about adding new nodes. I want to make a note here. It is about actually adding new partners that come with their own nodes. Okay, so those partners that join your consortium are actually usually should be bringing their own nodes. And what is important here to consider is that onboarding of business partners on a consortium could be actually onboarding on preset network. What I mean by that is that those business partner may not necessarily have nodes with them. It could be a process where someone provision nodes or the consortium provision nodes for those partners and onboards them. Or the other option, of course, is when the partners that are joining are already part of or already run nodes, and they just want to add their nodes onto the network and start being part of the transactions. So that is, I have a picture, nice, hopefully you're gonna like it in a while to make it more visual, what I mean by that, because I want to put it in a context. In my case, it's a supply chain context, very easy to explain, very intuitive to understand. So scaling your nodes, orders, and peers, as I mentioned, vertical and horizontal scaling. What is, however, tricky here is that when the business partners on a consortium host their own and manage their own peers and orders and nodes, let's put it that way, you don't have a centralized or central control of the scaling mechanisms. You don't have usually, in many cases, in some you do, but you usually don't have a central party actually to manage the nodes of every participant on the network. So when we're talking about scaling, you have to think about it as, in most cases, of course, as efforts that needs to be, or steps that needs to be taken by every participants on the network individually. Okay, as soon as you put the whole network in a single, let's say, cloud provider or on a single Kubernetes cluster, if you wish, to actually streamline and to make the scaling more simple, you're essentially centralizing everything. In some cases that might make sense, but in many cases that defeats the purpose of using distributed ledger technology, because essentially, even though they are distributed, you're still centralizing them on the same infrastructure. And horizontal scaling from Hyperledger Fabric perspective, that is essentially adding more computational resources. Nothing, strange here. It's a regular vertical scaling for the purpose of actually handling more load in a particular point of time. So have in mind that the transaction endorsement in Hyperledger Fabric may require endorsements by different participants on the network. So the overall transaction throughput and handling of the load actually is going to depend on the performance of those peers managed by different partners. So let's take as an example, think about it that two partners are actually hosting peers, and one of the partners is actually able to add, like, let's say, new CPUs on their infrastructure to handle the load of the transaction during lunchtime, because their users decide to do most of their daily transaction during lunchtime. So they want to make the system available. Now, let's assume as well that every transaction is endorsed by the peers of both partners. So for a transaction to be processed, it needs to be endorsed by the peers of the two partners. So if one of the partners scales their nodes up vertically to handle, to speed up the transaction endorsement, if the other partner doesn't do the same, of course, that will reflect on the overall time to commit the transaction. So that means they need to work and measure that performance together as a whole if they want to have a valid impact, or let's say positive impact on the transaction throughput. So it's what I mean to say here is as well that it's extremely hard, unfortunately, to synchronize those efforts in reality. Let's be realistic right here. You cannot expect that. Now imagine a network of 10 partners. How are you going to synchronize the efforts to actually scale up and increase the transaction processing? So that's why it's essentially very important that those efforts are planned accordingly between and agreed between the partners. Seen actually many cases where like the businesses, they usually let those efforts be managed, or let's say performed, by skilled engineers who know what they're doing. So if you actually if you're a small partner, let's say a small business without even IT department, how are you going to do that, right? So essentially, when you scale those permission networks across multiple partners and more partners you actually board on the network, more complex it becomes to handle scalability properly. Okay. So when people are talking about transaction throughput and saying, hey, how many transactions Hyperledger Fabric or whatever X technology can process on the chain, and people come up with measurements. Usually those measurements are taken out of a test system where everything works in one box. But that's the best case scenario, but that's not realistic. So when you actually try to scale, think about those things, and I would say the expectation of the transaction throughput is a function of, or actually the transaction throughput is a function of the performance of the peers of the nodes of all participants on the network. You cannot expect that one of the partners will actually scale up their peers and the transaction throughput will fly through the roof. That usually won't happen. For essential transactions, of course, it all depends on the endorsement policies. There are cases where endorsement is required just by a single person, by a single partner, and in those cases, a transaction can be endorsed by a node that's scaled properly. And then we are talking about a single party controlling the transaction throughput, because it's much easier to manage and to do it. Okay, so this is a picture here of how we actually add a new partner on the network. Here in my example, as you see, I have in the circle an existing consortium of processor, farmer, and retailer. Think about that these guys are actually tracking lettuce on the network from the farmer to the retailer shelves. And in that case, they want to scale their network by adding the regulator. So the regulator can jump in their nodes to be part of the real-time transaction processing. Have in mind that by adding the regulator on the network doesn't necessarily mean that you're gonna have lower transaction throughput, because the regulator may not endorse transactions and no, it could be just a committer or a reader, right? So here we were talking about scaling your network in terms of not adding peers, but adding new participant on the consortium. Now, talking about the supply chain example, I explained that before, that the network resilience in general supply chain is very tricky topic. Why is that? Because there are many businesses out there that run or use many suppliers or vendors, and they may not even understand what's going on down below the chain, right? So they may be working with a vendor, and that vendor may work with contractors, smaller companies, smaller vendors, and whatnot. So when you're talking about creating a network between your suppliers for your supply chain, and having your suppliers or vendors being part of the network, of course, you could expect that this will happen on different cloud providers. So that means think about a company A that works with company B, and company B works with company C, right? So all of those companies may have different relationship between them. They may not even know that they work with each other. So the onboarding and the deployment of their Hyperledger Fabric peers, assuming they use Hyperledger Fabric, of course, will be driven and handled by each company individually. So you cannot expect essentially that they will bring all of their nodes on the same cloud provider. So what you need actually to achieve with the multi-cloud deployments is to actually have the decentralization of the infrastructure. So you have high availability. The same for geographical distribution. If a zone, goes offline, you don't want to risk too much by hosting your peers in the same data center. right? So because in that case, even if you have 10 peers, if the data center goes down, you're going to lose all of them. So that's why you want to actually distribute them geographically. And that's not the only reason why you want to do that. Think about international consortia. You may have partners working together across continents, right? One in North America, one in Asia, and they may have their peers pretty far away, right? So here now we are talking about network latency, right? So when they talk between each other, depending where the client is that's performing the transaction, the latency of the network is gonna play a big role in your transaction throughput, right? So that's why different companies, even though they might be located in Asia, they may have to actually provision peers, not just on different cloud providers or maybe the same cloud provider, but they may want to provision peers or nodes in different data centers in different regions. Because if a transaction runs from North America and the company in Asia have peers in North America, so the network latency is going to be much faster. Latency will be lower, and therefore the transaction will go much faster. So it is very sensitive thing on how actually to distribute your nodes properly for your particular network or particular consortium to have the best transaction throughput and availability, network availability. So another thing to consider, of course, partner peer availability. That's another thing that's important. As I mentioned before, you may have use cases where multiple partners need to endorse transactions. So if one of those partners, one of those endorsers doesn't have proper doesn't build their nodes properly, so they may just decide to go with one node, and that node goes down, then none of the transaction will go through. Okay? So that is essentially very important to actually have the proper infrastructure, the proper setup, not only within the concept of a single partner, but across partners. Okay, so how a single participant network may look like. So here I'm having 3 data centers, and as you see, they provision different nodes in different data centers. Of course, the nodes communicate between each other over internet, which is a good thing. So you can actually not just provision them in different data centers, but you can essentially use different technologies to manage the network and the nodes. You may use Kubernetes or Docker into different, or just run it on a physical machine. So it is essentially one network, but built and running on top of different infrastructures in different geographic locations. Okay. Okay. So and here is how a network of different a consortium of different partners look like. So you see, they may be part of the same channel, and each of their nodes may be running onto different bubbles. Like here is, I mentioned Docker, but it could be internally variation or a union of running the peers, the nodes on different infrastructures and different technologies. Of course, when a transaction goes, as I mentioned before, it is important that actually every one of the endorsers on the transaction have their nodes available and their availability managed properly, because if one goes down, and endorsement is required by all of them. That's a very important thing. It all depends on the endorsement policy you're using. Then it will affect the availability of the transaction as a whole on the tracking channel. There are cases though where you may want to have a single endorser for the transaction, as the others would be just committers, or they will be just reading the output of the transaction, the result of the transactions, or the data that's been recorded on the ledger, put it that way, but they won't be active participants or participate in the endorsement process. So by having that endorsement focused on particular or done by particular partner, then the whole transaction throughput essentially in general or mainly will depend on that, on the speed and then the processing power of the nodes of that particular participant. Yeah. So it's essentially extremely important to define your endorsement policy. There might be cases where the endorsement policy is enforced by the business because less partners you have to endorse the transaction, higher the risk is of losing completely the capability of processing transaction in case that partner decides to leave, right, without telling you. And that's why you may want to go, of course, with the transaction endorsement policy that requires transaction out of the transaction with endorsement policy that requires endorsement by particular or a percentage of the participants on the channel instead of making it specific. So you could ask for majority, or you could ask for a subset of the participants on the channel to endorse a transaction. Of course, if you're running a transaction and you'll be having good throughput, and tomorrow you decide to change the endorsement policy and you add another partner to endorse, and that partner does not fit the bill with endorsing properly or endorsing with the right speed, that may have, of course, side effect on the general throughput of your transaction on the network, on the channel in particular. Okay. So that is the last slide. I think I fit within the 30 minutes timeline. So I would like to open a question, or if there are any, I don't know, Laszlo, if we have something on the chat. I see we do.
Yes, we have RG asking why is Peer 3 in Azure Data Center?
Okay, so wait. What is that question? Is that so? I'll just read it aloud. So I think IBM is going to integrate Hyperledger Fabric network in its Cloud Foundry to provide it a global secured network. Am I right? Well, let me be honest. Hyperledger is just a bit misleading here. I just want to keep on repeating that every time. IBM is not Hyperledger, and Hyperledger is not IBM, right? So they're different. Hyperledger is open source community, right? Part of Linux Foundation. It's Linux essentially. So the partners, they will, even though a partner might be part of IBM blockchain network, I don't think businesses has to be limited to actually, or constrained by the vendor of their nodes on their decision with what businesses to work. I think many of the businesses out there they use different cloud providers, different infrastructures. So that's what I'm saying is that communication between those nodes, regardless on what cloud they run, being it IBM, Hyperledger Fabric, Hyperledger, what's that, Hyperledger Network or Foundry or Azure, blockchain as a service, Hyperledger Fabric as a service, or AWS as a service. It doesn't matter. Those cloud providers are not supposed to constrain a network or a consortium that is actually combining nodes run on different cloud providers. It's counterintuitive from their business point of view. They don't want you to do that, right? So they want your partners to run their nodes on your own cloud provider. Reason is, of course, revenue, right? But I don't think that makes much sense, because you cannot actually ask one single partner to provision nodes on 10 cloud providers just because a consortium can run only on a particular cloud provider. That doesn't make sense. The cost is so high. Forget about justifying running an application based on such network, right? So you cannot like invest millions of dollars on maintaining nodes on different cloud providers just because they're constrained.
Okay, thank you. Let me ask a question from the YouTube chat. Ali Reza was asking, do you have any kind of Helm chart or sample piece deployment publicly available? And that,
Helm,
I think there was a question what Dan G was also trying to know.
Yeah, right. So there is for Hyperledger Fabric deployment, I guess, right? Network deployment and peer deployment. There are a couple of projects under Hyperledger Fabric already. There is one under Hyperledger Labs, and it's maintained by the community. It's a Helm set of Helm charts. It's not just maintaining or supporting Hyperledger Fabric. It also supports most of the other blockchain networks like Sawtooth, even Ethereum. So I would go and check that open source project first, if you want to do it manually, of course, because those are Helm charts, but they require extensive knowledge in Kubernetes to use it. I see. Yeah, I hope I answered that one. For the orders, yes, ordering service. I didn't talk about it. That's true. Yeah, let me say a few words about it. We now with 2.2 and up, 2.0 actually and up, the Hyperledger Fabric community recommends running an ordering service based on Raft. Okay, they well documented what that means, because you cannot scale Raft indefinitely. So there are limitations in terms of how many, limitation being, what makes sense. Don't get me wrong. Limitation is something that I would say recommended setup of Raft. Of course, you could try to bring up like 100 orderers to serve a particular channel, but that doesn't make much sense. People usually, there is a bit of misunderstanding when I talk to different people. Hyperledger Fabric, it's channel based, so we're not talking about a single ledger that is used by everyone on the consortium. We're talking about channels, and channels is a different instance of a different ledger. So the ordering nodes are actually since 2.3. They made it change the ordering service in a way that every orderer may actually serve different channels, and different channels can be served by different orders. So you can actually add or remove orders that are part of a particular channel. So that one actually gives you flexibility to actually manage an ordering node that is actually ordering transactions for different channels or different ledgers. that may not necessarily know about each other. And of course, Hyperledger Fabric community, let me just continue what I was about to say a minute ago, is that there is a limit to the efficiency of the ordering service based on how many ordering nodes you run. I had it somewhere, let me just look that up, but I believe that they recommend to have, for a channel, have that in mind. On a single channel, they are, I think, having about up to 11 nodes, okay, for the raft to work. So the raft itself, now one order can be part of different raft clusters. So this means think about the raft cluster serving a channel. One order could be a part of different raft clusters. And community is recommending up to 11 to maintain quorum, of course, for the raft protocol to work. And of course, adding more nodes unnecessarily brings complexity and doesn't give any value. So ordering service, keep it small, slim, and distribute between few partners if you want to, just for the sake of having reducing the risk by one of the partners going offline and letting your channel unserved. But yeah, it essentially should be kept to a couple of nodes.
Tsvetan, how do you monitor the availability of the partners and the overall Hyperledger network status? That's a question from Forehead.
Oh, it's essentially think about every partner. That's the way I prefer to think about it, as a endpoint or a black box. So think about, it's not about number of peers on the network. It's about number of endorsers on the network. And those endorsers are essentially, technically they're peers, but they're on the MSP or a partner level. So that means that it's a permission and private network. Don't forget about it. So if you want to know the metric of a particular node, for example, how many that particular node has, how many transactions that particular node has been has processed, and all of that, there is a metrics endpoint for each peer. And that can actually use Prometheus, for example, to collect the data, the metrics of the peer. That's the only thing that comes out of the community. So if you want to have, what I mean to say is that every partner may set up the metrics for their peers and have a holistic view of what's going on their peers. They may not necessarily know what's the metrics on the peers of their partners. Of course, what they know is through the service discovery is what is the topology of the network, but they don't know, for example, what their partners peers are running on, how many CPUs they're, what infrastructure they're running on, how much they've been loaded, because those peers of your partners may be serving different channels you're not part of. So you just have a view on the topology through the service discovery, technically speaking, and of course you have the metrics endpoint on each node you can use to monitor your own peers.
And if the infrastructure is geographically, located in different places where the latency is an issue, or latency is a constraint, is there any measurements or suggested KPI which, after the network doesn't support the transactions going through, or is it just the way the network is configured? I think that's the question alongside what another person asking through the YouTube channel.
It is all about how it's configured. Of course, you can do high transaction throughput. The complexity here and the real challenge is about how to synchronize those efforts between the partners on the network. You may not always have the chance to do that. And when you accept partners into your network, you have to ask your question how much of a importance the transaction throughput is for you. So if you have more distribution of the nodes and the partners, much harder it is to achieve high transaction throughput. So
I think also
it's a function that changes, right? So
yeah, but I think it also goes back to designing and planning the network, like what sort of data you want to store on the network, because the business might not need to store every single transaction, but maybe just a mirror of the transactions or some
right.
part of the transaction data to be stored on the blockchain or on the ledger. So I think it also goes back to the beginning where you started with planning and designing.
Yeah. And as I mentioned already, even though a business might be located in North America, for example, they may provision their nodes onto different geographical location to facilitate or to manage that network issue. So when you endorse a transaction, you want to keep your endorsing peers close to each other, right? With the client, of course, because that's the client that if you do endorsement with a client that runs in USA and the peer is located in China, let's say, then of course you could expect some kind of a slowness. But if the company in China provision peers in US and the client is in US, of course it will be much faster, because it's all about endorsement. I'm not talking about committing the transaction on different peers. Committing, as soon as you have like 10 peers geographically distributed, you are actually interested in making fast endorsements, so you can actually quickly send to the ordering service. And then your committing peer might be distributed, and the transaction committing phase is anyways asynchronous. So it could happen later on. Some of the peers might be out of date, of course, but they will catch up relatively quickly after the transaction is done.
Someone on the YouTube channel, I think referring to the diagram, what you have on right now, where you talk about different participants of a Hyperledger network, and specifically, I think small businesses like I can imagine farmers in here. However, farmers are not always small businesses. How do you see small businesses who have very low tech, infrastructure or resources in their company joining a Hyperledger network? Like, I think the question is how easy or how difficult is it from technical point of view to join an existing network?
Yeah, I think, and that's what my company is doing. The cost actually, as of now, to onboard, to provision the network, provision the peers is high, and it's not about that much. The cost is not that much determined because of the complexity. It's determined because of the people the skills of the people that perform the task. It's highly technical. Let's be honest. And you go and take a Helm chart, for example. Many people even don't know what Helm is or never heard of Kubernetes. You cannot assume that every business partner on a supply chain or every farmer will have an IT department and who by chance may know about Kubernetes. So it must be easy. And until that is closed by easy to use software, or maybe self-managed or managed by a software vendor at a low cost, you cannot expect that all of those small partners will justify being part of a network. They just won't. I mean, it's doesn't make sense for them. It's about money, right? And if they don't get back what they invest, even some of them don't care. So that's why reducing the cost and making it user friendly, easy, is essential and for the success of the whole technology. That's how I see it, and that's what we are trying to do. That's what we are doing at my company, trying to reduce that cost.
That's great. Thank you, Tsvetan.
But essentially, as I do think that most of the as of now, short-term kind of thing, most of the businesses that jump on a network, they will go with a service provider or a software vendor, right? Maybe small companies, maybe it depends on what they can afford, right? But do it yourself is we are far away. Maybe a few years until all the things are simplified to a point where a regular person with regular IT experience can do it by themselves.
Yeah, where the running network and setting up would be automated to a degree, will simple enough to.
Right. It will come. I'm pretty sure. It's not just us working on it. So community is also aware. So it just take time.
But I think it never will be like Ethereum or Bitcoin, where you download, a dump and you start up your node and start making transactions on the network as one of the essential and benefit of permission-based network, that you create a consortia, you create a collaboration, you create rules on the network. How do you want to transact? What are the rules? How you change them, and create trust between different entities. So I think it will raise a level of which customization will be needed or required. So I think there's time for one more or two questions, and one is from Maria Munaro. What impact does amount of channels, use of private data have on scalability?
Amount of channels. Channels with, as I explained, since 2.3, they actually, when you have a consortium, right? The whole point was about how many channels you may have between the particular set of organizations, right? More channels you have, that means you're bringing load on the ordering service. That was the key design issue, or it wasn't even design, it was like more of an implementation thing. Since 2.3, that's what they changed. So now you actually may have an ordering node serving X amount of channels. So you may have the same orderer or different orderers serving different channels. So you don't need to actually have one ordering service to serve thousands of channels. You can break them down in a way that a particular set of orders, as I explained, up to 9 or 11, to maintain a good performing craft cluster may serve particular set of channels. I think they come up with something that is how many? Let me cross check that. I think 50 channels on an ordering node. So if you need to grow more, you bring another ordering node, of course, to serve the rest of the channel. So that's been solved more or less since 2.3. So essentially, you keep adding ordering nodes to serve your additional channels if you're part of those, like hundreds of channels. Of course, managing those channels is a challenge. So I would be more concerned here about how actually you're gonna manage the permissions and the deployments on those channels than scaling the ordering service or adding an ordering node on.
Okay, so we are just 1 minute after the hour. If you don't mind to just address one more question, and in the meantime, do you have the time, Tsvetan?
Yeah, I'm fine.
Okay, just one more question until you answer it. I will make a random selection and draw the precious prize of today, the IBM blockchain original socks for today, if anyone interested who entered any questions. So the question is from David Evans. Can you talk about the MSP organizations to a network when they have their own certification authorities?
Well, every MSP have their own certificate authorities. That's how their logical entries, by the way, backed up or defined by their certificates. So when you're talking about membership service provider, you're talking about entity, logical entity defined by the certificates. What that certificate authority is behind that issues the certificates, it's an open thing. It could be any certificate authority. And it could be Fabric CA hosted and managed by the partner, or it could be their own existing certificate authority. So I know about deployments of use case where the company already have their own certificate authority and they use it to define their MSP. MSP essentially, as I mentioned, is a set of certificates and an ID.
Thank you, Tsvetan. And having that said, let's conclude this meeting. I'd like to announce that the lucky winner is Yakar Joseph Johnson. So Yakar, if you can send me a private message with your email address, or I can put my email address into the chat in here, and you can email me. If you're interested in the Zox, I'm more than happy to mail it to you. For the rest of the people, I appreciate your time for today, wherever you called in from, whether if it's a lunchtime in Eastern time zone, East Coast, or a morning session was for you in the West Coast. Tsvetan, I'm always enjoying listening to you and the knowledge you share, as now as in the past. I really appreciate your time as well, and
of course,
your contribution to this community. I think it will be great. I mean, great to see this knowledge spread away, and I'm sure a lot of people will leverage what you just shared with us. And I hope and wish all the best for your business as well. And if there is anything else you would like to share, please feel free to. Otherwise, just wanted to say goodbye. And and I will come back with the last note.
Okay, thank you, Laszlo. Thank you for the opportunity to be part of the meetup. Very well organized, and thanks for your time, and thanks for to everyone who joined the meeting, and hope they got something out of it.
I'm pretty sure. And everyone, please remember the Hyperledger Global Forum is going to be on the June 8th to 10th. It will be virtual this year, and remember to register and participate. Last year was amazing, really good presentations and speakers, so I'm sure it will be same this year, and you can join from the comfort of your home. Having that said, goodbye everyone. Have a good rest of the week, and keep an eye on our Hyperledger meetup group of Toronto for further announcement for future events. Thank you, and have a wonderful day.
Thank you. Have a great day.
Bye. Bye.